Hello, everybody. I'm Marisa Leinert, and welcome to COFAS 2022. Can you believe it? And COFAS standing for Conference on Faith and Science. And our theme this evening and for the next 2 days is Enriching Life with Science, Faith, and Virtue. It's based on the C.S. Lewis book, The Abolition of Man. Before we get started, I just want to welcome also the people online. Hello, everybody online. We have hundreds of people registered there, so thank you for joining us. I just want to let you know, and it looks like everybody's paying attention. You've got your masks on, so if you could keep that on during this conference, we would greatly appreciate it. And all the community questions, all the questions that you want to ask the speakers, they're all going to be through the Whova app. So if you have not downloaded the Whova app on your phone, please do so. That is how you are going to be able to ask questions for the speakers. That's how you're going to be able to participate. So please, we invite you to download the Whova app. And welcome again, everybody, for being here. We're so glad you are here. And I want to welcome Max, who is going to start us off with scripture reading.
I'll be reading from Hebrews 11, verse 1 to 3 and 6. Faith in action. Now faith is confidence in what we hope for and assurance about what we do not see. This is what the ancients were commended for. By faith, we understand that the universe was formed at God's command, so that when what is seen was not made of what was visible. And without faith, it is impossible to please God, because anyone who comes to him must believe that he exists and that he rewards those who earnestly seek him.
All right, so to begin our conference for tonight, we're just going to start with a word of prayer. So if I can ask everyone to either bow their heads or close their eyes or keep it opened. Father, Lord God, we just thank you for today. We thank you that you're with us. We thank you that you go before us. We thank you that you have prepared a way when there seems to be no way. Lord, we thank you for the seeds of faith that each and every one of us have here, Lord. We thank you for this time. You've stirred up many people's hearts for such a time as this, and you've called this conference to happen here at ASU. We are beyond grateful that we just get to partner with you, Lord, and get to come here and just learn from different people's wisdom and knowledge. God, we thank you for the technicians, the different people that are watching online, and we just ask that you constantly guard our hearts, guard our minds, and remember that we just keep you first in our lives and in everything that we do. So let us just come together in unity and celebrate this conference and go out with a blast today. In Jesus' name we pray. Amen.
Thank you, Chantel. First of all, I want to recognize the John Templeton Foundation for what you see around you. It could not have been possible without the grant and the support of the John Templeton Foundation, and to the Arizona Center for Christian Studies. And of course, there have been numerous other sponsors, too many to mention, but just know, thank you. Also, the two gentlemen to my left are the co-creators of the 4th annual COFAS 2022, as well as, oh my gosh, it took a team, a huge team, Misty Faulkner, oh my goodness, too many to mention. So just know these are the co-creators, but it took a whole team to get this conference going. So congratulations, Ben and Barry, for the amazing job that you have done in the last 4 years that you've created this. Tell us, what was your passion for having started not one, but 2 conferences back to back?
Yeah, whose idea was that? Well, yes, this is the second conference in 2 days. We've just finished the conference on religion, ethics, and science, which was a multi-faith conference. Now, this is a more Christian-focused conference. Everyone is welcome, of course. But this is something we've done over the last 4 years. We did our first one in person, if you remember those days. And then the following year, Grand Canyon hosted, and that was what I refer to as BC, before coronavirus. And then last year, we did a virtual conference, and which is, so our first time to do it in person was in 2019. First time to do it virtual was last year. And this is the first time to try a hybrid conference. And I simply want to say it's a different kind of conference.
A lot more work is what I heard.
And as you mentioned, Missy Faulkner has been working tirelessly on 2 conferences, and I owe her a big apology when it's all done, and a nice bonus.
There you go. And Barry and Ben, you were thinking about this 5 years ago. This has been a journey for you guys. Tell me more about that.
Well, I would say it's well more than 5 years, and Ben and I have known each other for maybe 25. And I think looking back on that period of time, there was a time here at ASU when I think we had a very healthy and robust environment to have conversations about faith and science, and not just the Christian faith, people of all faiths and no faith at all. And then we entered a period where things were really difficult. And I remember a dear friend of mine, a dear Jewish friend of mine, saying that the atmosphere had really become toxic here for having discussions. And that's unfortunate because there are a lot of people here who are really very generous souls. You're going to meet some of them during the course of this conference. And so the atmosphere may have gotten toxic, but the people weren't. And so, I think that part of our thinking over the past handful of years is to try to recover some of that. And, from the first in-person conference last year, just spectacular response. It's been really very heartwarming. I think we had, I don't know, I think you've got the numbers, Marissa.
Yeah. More than 1,200 from more than almost all 50 states and nearly 40 countries.
Yeah, so I remember at the time when you and I were on the screen together, just being blown away and by that, because we were people in Indonesia, and I forgot what time of, like 2 in the morning or something, were online watching this.
Bonus points to Indonesia.
Yeah, bonus points to Indonesia tonight. But of course, it's probably a more reasonable hour there now. But at any rate, for us, I think there are a number of other events, and Ben, you can talk about those, and you're much more familiar with them. But certainly for me personally, it's been the opportunity to re-engage with a number of friends who 15, 20 years ago, we would run events together and do things together. And so this has been a really rewarding handful of years.
Ben, you mentioned yesterday when we were talking that your goal is really a sense of community for the people here and online. Tell me more about that.
Well, I think ultimately it's always about relationship. Okay, so knowledge is great, but having friends and community who care for you, that's what makes life worthwhile. And I look out and not only those that I can see, but I know online many, many people who I think we're creating relationships and care for one another. And especially during times like this, that's when you need good friends.
And Barry, what can the attendees expect from this conference?
Well, I think the important thing to take from this is the role of virtues in the practice of science. You're going to hear from a lot of people who are scientists. Most of them, but not all, are going to be people of faith, but we'll talk about what it means to use those virtues. And as you see in your program, we've sort of parsed them out. We're going to start off in a moment or two with science and faith. But my hope is that out of this, those of us who are scientists, and those who are not, can see the importance of giving some intentional thought to the practice of these virtues in your life, not just in your church or in your faith community, but in your practice of whatever vocation you're in.
And Barry, can you introduce our next speaker?
It's my pleasure to welcome friends that we can have a little conversation about the role of science and faith tonight. First of all, let me do quick introductions. There are extended and extensive introductions, or rather bios, for all of these people. In the interest of time, I just want to give you a sentence or two. But please take a look online to see what a remarkable group of people we are going to be talking with tonight. Let me start off by with Jennifer Weissman. You can figure out which of the four of us she is. Jennifer Weissman is an astronomer, but also an author and a speaker. Her specialty is star and planet formation in the Milky Way. She is a fellow of the American Scientific Affiliation. Again, please look at her bio. It's just incredible, the number of attributes we have. She was unable to be with us physically, but she's here fully online with us. And so we're delighted to have you, Jennifer.
I'm delighted to join you. Wish I could be there in person, but this will be fun.
Terrific, terrific. Immediately to my left, your right, is my friend Andrew Briggs, who is Emeritus Professor of Nanomaterials at Oxford University, a fellow of the Institute of Physics, as well as the International Society for Science and Religion. His specialty, of course, is in nanomaterials and the applications thereof, but in particular quantum computing and the use of quantum computing and quantum computing algorithms in information processing. Again, that undersells him by a fair bit, and so please take a look at the bio to see more fully his background. So it's great to have you with us, Andrew. And then finally, over on your far right, I guess, is another dear friend, Paul Davies, who's Regents Professor of Physics at Arizona State University. He is the director of Beyond, the Center for Fundamental Concepts in Science. His specialties are many, but I would highlight theoretical astrophysics, cosmology, investigations into the nature and origin of life, and also SETI, the search for extraterrestrial intelligence. And so, Paul, it's great to have you with us tonight as well. For the record, I'm Barry Ritchie. I'm professor of physics at Arizona State University. I'm an affiliate of the Center for the Study of Religion and Conflict here at ASU. And my specialty is what I call experimental subatomic physics, because neither the nuclear guys or the high energy guys will claim me. And so I'll come in as an experimental subatomic physicist. So I wanted to start off, again, we want to start off with science and faith, and I wanted to start off with what is faith. And Paul, I want to start with you. 15 years ago, when we first became friends, you wrote an opinion piece, I believe it was, for the New York Times, and talking about that science is I don't want to paraphrase it incorrectly, so please correct me if I'm wrong, but science as an act of faith. And it stirred up a lot of people. A lot of people were frankly angry that you had made such a faux pas. And I think Peter Atkins got wound up about it. There were a whole number of people that were just incensed. He's from Oxford. I'm sorry not to.
And a very charming gentleman who took me for lunch at the Athenaeum Club, so we don't want to be too hard.
Okay, all right. So Paul, what did you mean by that science was an act of faith? Now,
well, I'm pleased you've asked this question, Barry, because had you not, I was going to lead off with this very topic, because young Matt here, reading from Hebrews, having faith in the unseen. Now, we're all physicists here, some out there may not be, and it's the essence of physics that we believe that there's a law-like order in nature, that nature isn't just arbitrary or absurd, but there's a hidden order. And the word hidden is important, because when Newton saw the apple fall, he saw a falling apple. He didn't see a set of differential equations that connect the motion of the apple to the motion of the moon. And yet they're there, and with sufficient effort, we can dig out the existence of this abstract subtext in nature. Some people call it a cosmic code. Doesn't matter what you call it. The thing is that the disparate phenomena of nature are connected deep down through mathematical relationships, which in their purest form we would call the laws of physics. And you can't be a scientist, certainly can't be a physicist, without having faith that there really is a law-like order in nature. It's in some invention. This isn't, it was fashionable some years ago to say, oh, science is a self-serving activity. Scientists invent these things, and then when they prove successful, they congratulate themselves and get more money and so on. There really is an order in nature. And if I say that the force acting on a planet from the sun, the gravitational force, is 1/4 if the planet is twice as far away, that is a really existing property of nature. These laws are, so to speak, out there, but we don't see them in daily life. They're hidden, but we have faith in those hidden things. So I think the very essence of doing science, and particularly doing physics, is having that faith used not in the term of believing in something that you can't prove, but faith in the sense of being faithful, or a reliance on something, an assurance that when we wake up tomorrow, the law of gravitation won't have switched in some arbitrary way. So it's an act of trust, then, is it?
Trust,
probably better than faith.
That you can take it to the
yes.
bank. That if you make a calculation. I mean, I think about the anomalous magnetic moment of the muon, which
yes.
those words mean nothing. But
well, shame on them.
But it's known to like 11 or 12 significant digits. So I remember the first time I was introduced to that, and I even tell my students that now, that that is more certain than, experimentally more certain than, the statement that the sun will rise tomorrow morning, because humanity has not seen that many sunrises.
Yes, that's an interesting comparison. Yeah.
And so it's a convinced trust, a trust built on having observed the applicability of those laws, and in your case, in many different spheres, from bio to astro, and so that's interesting. I wanted to bring that up.
And it's only 1/2 of what I want to say, but I'm going to save the other half for later, because it's not just a matter of believing there exists a law-like order in nature, but the fact that human beings can come to understand it. I think that's enormously significant. We'll come back to that.
Yeah. Okay. So, I think I want to turn to Jennifer. Okay. Now, Jennifer, when you use the word faith, I know that you're a Christian. When you use the word faith, is there something additional tacked onto that?
Well, I do think we need to, talk about what sphere we're thinking of when we talk about faith, because I totally agree with what was just said, that I have faith, or maybe trust is the better word, in science to be able to address the kinds of questions that science is designed for. So, and why? Well, I've seen that it works. I've seen enough evidence that the things that science tells me to expect from gravity or from radiation is trustworthy, and I can see that it's true, that I trust that what science predicts for some of the related phenomena that I haven't experimented on myself are also going to turn out the way that is predicted. So it is a kind of trust based on experience, based on enough information and enough trustworthy portals of that information that I can put my trust in the process, at least. And so the same is true, I think, in the part of my life that thinks about things that can't be measured with telescopes and microscopes. So perhaps the spiritual aspects of life. It's a lot of people throw around the word faith as though it's, like putting believing in fairy tales or something. And that's not what I mean. When I have faith, let's say personally faith in God or something like that, it's based on having enough personal experience and observing enough of what has been experienced by others, or is I see as reality in the lives of others, that I can put my confidence, even though I can't see everything and test everything myself. So for me, faith is informed trust. And it can be, you can have faith in different kinds of things. If you cross a bridge, you can have faith that bridge isn't going to collapse, based on your previous experience driving across bridges and based on your understanding of the knowledge of the engineers that probably put that bridge together, and your experience with regular testing of these kinds of transit facilities. And so you have enough knowledge that you're willing to put your trust that that bridge is not going to collapse when you drive over it, even though you haven't tested it yourself personally. And so you have faith in that sense. And then I think in the broader kind of spiritual realms of life, we can have enough solid information from experience and from people that we trust and from their experiences and from, I would say, even revealed truths that we can choose to put our faith in these things. So that's kind of where I would go with that.
So Andrew, would you add anything to that?
I love what both Paul and Jennifer have already contributed, and also the trailer for what Paul is going to contribute when we go back to the question. I think of faith as following the evidence, but going beyond the evidence in commitment to an action. And we do this in all sorts of areas of life. I'm a pilot, so before I take off in a plane, I go through the checklist very carefully. I do the pre-takeoff checks, so I'm following the evidence that the plane is safe to fly. But nevertheless, there's that step of faith when you go onto the runway and open the throttle and off you go, that it's going to be safe to fly on this particular occasion. And we do it in relationships, we do it in marriage, in a scientific career. When I accepted a research fellowship from the Royal Society, which was a 5-year commitment, that was a real step of faith, personally, that it was going to lead somewhere. And you can apply that to a particular experiment. I mean, Paul's talked about it in the sense of the faith that the universe has an order that can be understood. But it's also, when you do a particular experiment, it may be a very big commitment of time and money, and you have faith that it's going to be fruitful and that you're going to learn something from that experiment. And you can apply it to the Christian faith and say, well, you can read the evidence about Jesus Christ, but then the faith is following that evidence, but going to a commitment that goes beyond it. And I wonder if I can just elaborate a little bit about sort of two meanings of science that map onto two meanings of faith. You can think of science as a sort of body of knowledge. We're constantly getting this quoted in the UK at the minute. You know, the science tells us that we should do this, that, or the other. You're looking at your watch. Does that mean I'm talking for too long?
No, it means I have no idea what time it is. I just, I get in the, what is it, flow? I get in the flow, and so I don't know whether we've been here an hour or 10 minutes. Turns out we've been here 15 minutes.
Have to become a teenager, Barry, and look at your phone like that. It's 7:30 now.
Okay, all right, thank you. So it's been 15 minutes.
You can think of science as a body of knowledge, a body of knowledge that's reasonably well established. You know, science tells us that the universe is 13.8 billion years old, or whatever it is. But you can also think of science as a methodology, science as a way of asking questions, science as a way of finding things out, as Jennifer said, within the scope of its self-imposed limitations. And I wonder if that maps slightly onto faith. You can think of faith as a sort of a body of beliefs and practices and communities, as in the Christian faith, or you can think of it as a way of making progress in life in general, but specifically in your spiritual life, that you exercise faith. And I wonder if that distinction may sometimes be useful, both when thinking about science and when thinking about faith.
I think it very well may. I mean, I'm interested because so far I think all three of you, and I agree, believe that faith is built on the evidence that you have seen in the order of the universe, and so forth. Earlier today in the previous conference, Andrew, I remember you talking about the particularity of the truth of the Christian faith. And though we didn't go into it then, the point was that you felt it was evidential that this was about a particular person at a particular time, that was God incarnate. And so for you, and I assume for Jennifer as well, that part of your life, that part of the way you look at the universe and understand the universe to work is informed by evidence as well, that it is not something that you believe is a cleverly devised myth, that you believe that in fact it is grounded in evidence. I think the opening verse of the Hebrew Bible is the opening verse of the Christian Bible, and that is, in the beginning, God created the heavens and the earth. And to have that stated at the very beginning, and we can go with the rabbi, we can go through all of the commentaries and everything, but it is a statement that's boldly asserted as a fact about the universe in which we live. And so I think to be a person of the Jewish faith or a person of the Christian faith, that is foundational to you understanding why there is this set of laws, why is there this regularity, and so forth. And so I think it's been interesting, again, that all of the discussions of faith here, including Paul's statement that science is an act of faith of sorts, is a motivated trust, a trust motivated by evidence. Now, it is common in science to disagree about what the evidence means. That's what makes being a scientist an interesting life. By the same token, obviously, the evidence that you mentioned earlier today and that we just discussed is evidence that not everyone accepts as a statement of fact, or that these facts could be interpreted differently. But I think that we've reached agreement here amongst the four of us that this idea of faith as a motivated trust, a motivated belief based on evidence in a proposition is something we agree on. I think that with that definition, and again, we talk about the Christian faith, we talk about our faith as being a scientist. John Polkinghorne wrote this wonderful book about the faith of a physicist, and essentially goes through the parts of the Apostles' Creed and how he, as a physicist, approached those elements of the Apostles' Creed. I remember having a conversation with him once, and said something about him being a process theologian. And he said, "Well, you Americans are big on labels." And so I've learned not to use labels for that. Let me ask you, and again, I'll start back with Paul. Now, again, this is a conference where we're going to be talking about virtues. Paul, do you see faith in the sense that you have faith in science? Is that a virtue for you as a scientist?
Well, I think I said earlier you couldn't really be a scientist if you didn't have faith in not just the laws, but the scientific method. You'd be a fraud. I mean, you could do it, I suppose, but it would be a bit of a sham. So certainly you need to have some sort of faith, not just in the law-like order of nature, but that the scientific method will uncover meaningful new information. And Andrew already hinted at this about he goes to a lot of trouble to do an experiment in the expectation that that will be rewarded, that what he will find isn't gobbledygook. If we take an example that people here might be familiar with, the Large Hadron Collider, it's the biggest machine ever built. 27 kilometers in circumference. It's a ring-shaped tube that sits beneath the Swiss-French border, and it accelerates protons in counter-rotating beams to enormous energies, and then these protons smash into each other. And the reason it was built was because in the early mid-60s, a number of theoretical physicists, most notably Peter Higgs, came up with a mathematical scheme for how the weak nuclear force and the electromagnetic force might actually be united or merged or amalgamated in a common mathematical scheme. And that predicted the existence of a particle with certain properties, which became known as the Higgs boson after Peter Higgs. And that was in the 60s. And generations of particle accelerators were built, and the Large Hadron Collider was built a sum of 8 billion euros in order to test this and to make the Higgs boson. And it did. It was duly found, and it's a famous discovery, one of the biggest discoveries of the 21st century. So that's all great. But it illustrates the point that building this machine, which took a lot of brilliant engineering and a lot of money and a commitment, was done in the expectation that even if the Higgs boson wasn't found, something meaningful would have come out of it. Now, this is a level of investigation in nature that had never been done before. So it was opening up a new frontier. It was going the next level down in the expectation that there would be rational order, that what came out of it would make sense. And that is what, for me, is the most impressive thing about doing physics in particular, is that you may have a lot of confusing data. Back in when I was a student, nobody knew really about all these particles. Barry, you would remember. I mean, they ran out of names for them. They were finding new particles every week. Some of them just had numbers attached. How could you make any sense out of all this? And yet there was that belief. Murray Gell-Mann in particular carried this forward, a belief that that somehow it would make sense, that there would be some sort of mathematical relationships that were connected all together, and there would be some sort of underlying, there'd be a deeper level at which it would make sense. And making sense, so for me is the really critical thing, because you can work on a problem mathematically. So doing theory, how do we understand this? And then there can be that aha moment when it all falls into place. And the fact that the universe makes sense to us when we get to that stage, I think is enormously significant, because if we can get sense out of the universe through science, somehow something like sense or rationality has got to have been put into it in the first place. So I'm not sure, I mean, I've been rambling a bit, whether I actually answered your question. But
I think you did, and you gave an excellent example that for heaven's sakes, for 50 years, there was faith that the Higgs boson would be discovered.
Or that something that would fulfill the same role, maybe, but that it wouldn't be nonsense, that it would make sense.
Yeah, and that they would put billions of euros into this.
Right.
And so certainly that was treasured as a virtue, that we really think we understand things. Now, Jennifer, in our conversation over email, you mentioned that you were aware of a project where they discussed virtues in science. Can you tell me a little bit about what some of the virtues were that scientists felt were valuable?
Sure. So this is Dr. Pennock's work. I can't really give justice to this research off the cuff, but the idea of this research was figuring out what are the virtues that scientists really operate under and value. And are there virtues in the practice of science that are very important and pivotal for science to be successful? So this is a kind of topic that isn't often framed in this way in scientific circles, and yet we very much value virtues of integrity, virtues of truth, virtues of accuracy, virtues of motivation. And so I think we're also realizing now that science itself is not completely objective. It's no way can be, because it's basically framed and carried out by humans. And so, science is very human, and we can look back and see that the way science has been done in the past has often been ethically fraught, sometimes just downright immoral and unethical, the way science has been carried out, or the types of research that has been done. Think of the Tuskegee experiments, things like that, that are things that we are ashamed of now. And science moves along with the good and bad of humanity. And so it is important to keep doing introspection about what virtues are important for us to get out of whatever we do in life, what we hope to. And in science, we're hoping that we're investigating fundamental truths. We're hoping that we're getting to the bottom of questions and truths, and that we can apply them in ways that apply the knowledge in ways that is actually helpful and constructive. But we have to always keep looking at who's doing the science and what kind of perhaps unintended biases are going into how the science is done, how it's selected. There's a lot of attention now on artificial intelligence, and a lot of the coding that's put into great human efforts like healthcare and so forth. Well, people putting together models and frameworks and computer codes to model human health and so forth, turns out have biases, maybe not intended, but coming through, that end up in the predictions of who's going to benefit from certain healthcare practices and so forth. And so even in unintended ways, there can be damaging biases that work their way into the way science is used. I recommend the work of Dr. Ruha Benjamin. She's been studying racial biases that work their way into our technology and into our coding and things that actually have great influence on our human culture and society. So I can't speak to this kind of work because in terms of the research results, because I haven't done it, but I know that virtues and looking at the nature of humanity and how that influences the very technology that comes back and influences us again, it's a circular thing, is something we have to be mindful of.
Yeah, I glanced at that study a little bit after you mentioned it, and the top virtue was honesty, that it was essential that you be honest. And that I was reminded of that. There's this website that I like to keep track of called Retraction Watch. And it essentially looks at, publishes when major retractions are made. And earlier this week, a person had 110 papers retracted at the same time from the same journal.
By the same author.
By the same author.
Yeah, yes. A great retraction
that's
record
right.
on your CV.
And that's right. And he, in fact, jumped to third place on this list, this list of shame, the Hall of Dishonor, for the number of retractions. And
Does he get a place in the Guinness Book of
Well,
World Records?
prize of some
Great
sort.
number of retractions.
For a single blast, it may be the worst ever. But honesty then is certainly a virtue that we put higher than perhaps others. I want to say that number 2 was curiosity. Now, we don't normally associate that with being a virtue. We normally say that that's more a
With a cat, it results in its demise.
That's right, yeah. So for scientists then, that is important. So
I
beyond,
should tell you, Barry, I read a book which some people here may have read called The Penultimate Curiosity, and there was a conference about it in Oxford. And one of the contributions at the conference from Pete Jordan was a wonderful paper on the ebb and flow of curiosity as a virtue over time. So there have been times when it's been indeed considered as a virtue, and there's been times when it's been considered the opposite, as in sort of nosiness, you know. So curiosity is a virtue that needs to be curated carefully.
Could I throw in a commercial for John Templeton, seeing as the John Templeton Foundation is sponsoring this event, because he was a great fan of humility. And humility is a virtue, and in the scientific community, we are supposed to be humble in the sense that that however passionate you may feel about a particular theory or piece of work, we can see that nobody has the last word, that it's always open to revision or further progress, and that we make a contribution. And the idea that that's the way it is, I've figured it out, it can't be any other way, I don't want to hear anything else, would be considered unvirtuous in science. So it's not to say that there aren't scientists like that, but the community as a whole, I think, does police that humility. And John Templeton was very struck by that.
right, and that in fact again was on this list of virtues in the study that Jennifer mentioned there a second ago. And
Yeah, if I could just interject real quickly, I just want to make it clear that we're talking about the research of Dr. Robert Pennock of Michigan State University on virtues in science. So that's very worth looking up.
So I think we agree that there are a handful of virtues, and we've touched on motivated trust, which is what we called faith up at the start of the things. The one about humility, I think, is interesting too, because you know, there's a problem if humility is not part of your general makeup. It's tempting to be smarter than your data, smarter than your equipment. I generally teach students that you have to be smarter than your code, the code that you're using to analyze your data. But that humility that you spoke about is essential in terms of being willing to say, listen, this data does not support the proposition that I have laid out. And that type of humility is so essential that I'm sure that if you looked at this 110 retractions, 110 times this person was told the data was wrong. It takes more than chutzpah to hold, you know, to continue publishing when you have that many opportunities to come clean about something.
You probably know the humorous story about Einstein, the bending of light experiment. Eddington tested in 1919 the eclipse, a total eclipse of the sun, and conveyed the results to Einstein. Einstein's assistant came in and came into his office and showed him the outcome of those measurements. And he didn't seem that interested. And she said, but, you know, aren't you excited by the fact that your theory has been confirmed by this observation? And he said, and she said, what would you have done if it had been a different result? And he said, then I would have felt sorry for the dear Lord, the theory is right.
All right. Okay. So
the opposite of being humble.
That's exactly right. I mean, God was mistaken somehow. So how does then, if I can turn to, let me turn to Jennifer first then. How does the practice of faith, honesty, curiosity factor in to your life as a Christian? How does that, well, let me put it another way. How does that influence your pursuit of science? And how does your science influence your faith in terms of the pursuit of those virtues?
Oh, that's a great question. So I think for my story personally is that I grew up in a rural area, and I grew up in a home of a Christian family, and so it was natural for me to hear about the faith, to experience people living out their faith, and also to experience the natural world. It was easy for me to walk out at night and see a night sky full of stars. We didn't have much light pollution. I lived out in an area where I could wander around the meadows and explore streams and lakes and rivers and forests, and really grow to just love the natural world and wildlife. I love animals, things like that. So it was easy for me to see the beauty of the natural world and understand from what I was being taught in my faith upbringing that everything in the natural world is a gift from God. And so it wasn't too hard for me then to see that science, which is the study of the natural world, could be a way of sort of living out an appreciative faith. I never really saw any need for some kind of conflict between religious faith that we were brought up with and science, which is, to me, studying the details of how the natural world operates. I know some people have had more kinds of conflicting experiences, especially when it comes to trying to figure out how to interpret certain very specific scriptures in light of what we're learning with some very specific science. But I think I was raised also with a sense of humility, which has served me well even to this day, which is that while in my faith tradition, we take the scriptures very seriously as a portal for God's word to us, we humbly recognize that those scriptures don't give us all the details, that God has given us other gifts of faculties and of the ability to have curiosity and to investigate. And in more recent centuries, I would call it the gift of science, to really find out some of the details of God's creation. And so for me, science has been a wonderful pathway to understanding some of the details of the natural world. It fits very well in with my understanding that God is good and is responsible for the natural world and would want us to know more about it. It gives honor to God to know more about the details. And I would also say that I am a very curious person about the natural world. I found ever since childhood that space is fascinating, and the more we're learning about it, the more questions we have. And so I think we live in such a marvelous time where, for the first time in human history, we know for sure there are planets outside of our own solar system. And it's only been a century that we've known that there are other galaxies with hundreds of billions of stars outside of our own galaxy. And so for me, faith set the stage to have kind of permission, if you will, to study the natural world through science. And then what we're learning through science in my life comes back and enriches my faith. I realize how incredibly imaginative and powerful and creative God is, to have sponsored a universe operating under the laws that it does, and how the universe has evolved over 13.8 billion years under these natural laws. That to me enriches my appreciation and my faith in the God that I love.
Yeah. So as I was saying in the green room there a few moments ago, Jennifer, I think we need to do a study about young girls in Arkansas and astronomy, because there are a lot of young girls who grew up in Arkansas who became incredible astronomers like you. So not quite sure what the connection is there, but like you say, it may simply be that you could see the sky. We certainly can't do that here in Phoenix. Young girls.
Well, I tell you, it is so sad that humanity is drowning out our own view of the of the night sky, and it's really kind of unnecessary. We can simply dome our lights and dim the lights, and we can get our night sky back. But that's another. Can I show a picture real quick? Would that be all right?
Sure.
Okay, I just can't help as an astronomer. I can't help.
I knew it. It better not be a graph. I remember back when we were a Department of Physics and astronomy, you think, oh, I'm going to go to an astronomy talk and there's going to be these beautiful pictures, and it was all graphs.
Oh, you may be saved because it says the host has disabled participant screen sharing.
Oh,
so,
okay. All right, there's a gentleman working on it right now, even as we speak.
We'll get back to it.
Well,
Okay.
we'll get back to it anyway. So we'll get back to that picture. But is it ready yet, gentlemen? Not yet. Nope. So hang in there. So Andrew, I wanted to bounce that question to you as well. I mean, faith informing science, science informing faith.
I mean, I love everything that you said, Jennifer. So rather than repeat that, let me just take a different angle on it, which is
you wrote a book on the penultimate curiosity.
Well,
yeah.
I mean, I'll gladly tell you what that was about. That was a journey that an artist and I did, Roger Wagner, through the evidence, really, of how time and again science swims in the slipstream of ultimate questions. And what I mean by that is that where you have a culture or a community, or it could be an individual who's interested in the big questions of truth and purpose and meaning, and what is human flourishing, and why are we here, and what is God like, and how can God be known? These sort of big questions. Time and again, that has proved conducive for the curiosity about the material world that leads to the kind of science that I do in my laboratory, and that in their different ways Paul and Jennifer pursue. We mentioned the Higgs boson and the faith that was needed to create the Large Hadron Collider at CERN. But there was a prior bit of faith in the person of Peter Higgs. It happens that I sit on the Science and Engineering Fellowships Committee of the Royal Commission for the Exhibition of 1851. And Peter Higgs
Were you a founding member?
Pardon?
Were you a founding member?
In 1851. I'm not as young as I look. We got quite a good record. Peter Higgs is the 13th holder of one of these fellowships to go on to win a Nobel Prize.
Wow.
And he was awarded a fellowship to do something quite different. And after a year or so, he wrote to the commission and said, I've got something else I'd like to investigate. Would you be happy for me to do that instead of what I put in my proposal? And the commission, very wisely, had faith in Peter Higgs as a scientist and said, yes, by all means, pursue this other thing. And that was the work that led to his theoretical discovery of the Higgs boson, which was, experimentally
Did he ever complete the original project?
No, never. And nobody minded.
I was about to say, no one asked for the money back.
I grew up in a musical family, so it was quite common as little kids, last thing at night, Dad would play the piano and sometimes sing to us. And there was the pleasure in the music that was inseparable from the relational dimension, that it was Dad's way of communicating his love to us. Years later, as you say, I wrote the book with Roger Wagner, and I'd known Roger since student days, and rather remarkably, I knew Roger as a person before I came to know his paintings. And so as later he produced the paintings, and we now have the largest collection in the world of his early paintings, there's the pleasure in the paintings, which anybody can have, who looks at the pleasure at the paintings. But for me, there's this extra dimension, this relational dimension, because I know the artist and have a relationship with him. And that's perhaps a rather feeble, but I hope helpful picture of the way that if you have the privilege of a relationship through Jesus Christ with the Creator God, then, well, anyone can have the pleasure of science if they devote themselves to it and they've got the right sort of mindset. So without any belief in God, you can have the huge satisfaction of understanding something that you hadn't understood before, and possibly occasionally of understanding something that nobody had understood before. But if it's in the context of a relationship, well, you get the picture that I'm driving at. That gives an added scope to the pleasure and the enjoyment and the reward, and I suppose also to the responsibility of the use that you subsequently make of what you've been privileged to learn.
Okay. So do we have the ability to post pictures at this point? No, I got the thumbs up. So all right, Jennifer. And again,
All right, we'll
better not
try
be a
this
graph.
again.
Better not be a graph.
It's not a graph, but I just want to show you, you know, some things that have. Can you see? Can you see?
Yes,
This
it's
beautiful?
working.
Yes, beautiful.
Yeah, there are things that motivate people, regardless of whether they're people who hold faith or not, but who unite. These kinds of things unite us, I think, in a sense of wonder and awe and appreciation. And so I love, for example, this image of a recently formed cluster of stars. Stars are still forming. That's one of the things I began to learn as I began to study astronomy professionally, is that the universe is not stagnant. Stars continue to form, such as in this region, and then the light from those newly formed stars lights up and ionizes the surrounding gas, and that's why you see the beautiful colors here. We astronomers use different kinds of technological tools, space telescopes, telescopes on the ground, radio telescopes, to study different aspects of the universe, but we need all those tools together. And this is a way, I think, where technology fits hand in hand with, of course, scientific progress. And then those scientific discoveries go back and feed the bigger questions and values that we have of who we are as human beings. So it's all interconnected there. I myself became a radio astronomer after being trained in college and graduate school, and began to study how stars form. And finally, I just quickly, I know this isn't an astronomy lecture here, but we're learning so many things about our own solar system and galaxies beyond. And let me just show this amazing deep field. Talk about curiosity. This is one of the most famous astronomy images ever. And it was basically a shot in the dark, a curious look at in a direction of space where there weren't many nearby stars to drown out the image. And the Hubble telescope was just poised there to collect light for several days. And some scientists thought this would be a waste of time, of precious time on the telescope, to just look at basically nothing. And yet what appears when you allow the faintest light to be collected and integrated over days are these collections of galaxies. So each little smudge in this image is not a star, but rather a galaxy like or unlike, but a galaxy. Our Milky Way has hundreds of billions of stars. These little smudges of light have billions or hundreds of billions of stars in each one. And if you look at any direction of the sky, you'll see something similar. This is just like looking through a drinking straw in our universe. It's enormous. And so by simple curiosity and looking, not knowing what we might see, we found a rich universe. And so then that has fed back to many scientific questions about the content of the universe. And we can even use telescopes like a time machine, because it takes time for the light to get to us from galaxies, and the more distant ones, it's taken longer for the light to get to us. So we're seeing them as they were earlier in the universe. So if you spread them out like in these circles, from the most distant galaxies on the right to the more nearby ones in space and time on the left, you can see that galaxies have changed over time. They've merged, they've gotten bigger. If you study their chemistry, you can see that generations of stars have come and gone and created heavier elements that we need for life. So we can actually see that the universe has evolved over billions of years to produce the elements we need for planets and life. And so even there are cells in your body today that were produced by other stars that have exploded and spread their material out, and it's been encompassed into our own solar system. So I just wanted to share some of this majesty to you, because I think a virtue of curiosity and the willingness to explore is something very fundamental for scientific discovery and progress. And it is curiosity, I think, that's motivated my own interest in going into science and astronomy as well.
Terrific. Well, thanks for sharing that anyway. I want to move a little bit further and actually talk about, I mean, we've, I think, established that the pursuit of science is grounded in our trust in the law-like behavior of the universe, that it's the conversation we've had is that it's a law-like behavior that is comprehensible. There may be limits to that. Obviously, there may be limits to what we can comprehend, but that what we do comprehend is incredibly beautiful. I mean, one of the reasons why I feel sometimes I have the greatest job in the world is I get to teach the classical subjects, not quantum, but I get to teach classical mechanics and classical E&M. And to me, even those classical subjects already have such incredible beauty, particularly electricity and magnetism is just this beautiful classical field theory and so forth. So I wanted to ask about beauty as a motivator for science. And is that a virtue? So Paul, why don't we start with you?
Well, I'm a great fan of beauty, and in physics, there have been many examples of where some sort of aesthetic sense has led to profound discoveries, and our audience may be totally baffled as to what I'm talking about. In particular, mathematical beauty. A lot of people think mathematics is simply straight ugly. How can you have beautiful mathematics? But believe me, you can. And a couple of examples. We're always told in writing popular science books that every equation halves the readership, you see. So you're not allowed equations. But my latest book, which is called What's Eating the Universe, I sneakily got away with a couple of, well, there is one exception, E equals mc squared, you're allowed that one. But I sneakily got away with a couple of other equations by showing tombstones, or plaques from Westminster Abbey. So if you go to Westminster Abbey in London, there are a couple of equations. One of these is Dirac's equation, and Paul Dirac combined the theory of special relativity with quantum mechanics to describe the electron, and as a result of that discovered something called intrinsic spin. I'm not going to go into the details, but the equation is truly beautiful. It's very compact, very few symbols. Doesn't matter what the symbols are, it encapsulates a very profound truth about the nature of the world and how it's put together. And you can see that if you go to Westminster Abbey, you'll see it for real, but you see it in the book. And the other one is Stephen Hawking's headstone, which has his formula for the temperature of a black hole. Again, a very simple equation, very beautiful. So what does this mean? I want to give you just one example, seeing as Barry mentioned the beauty of the theory of electricity and magnetism, and I completely agree with that. And there's a very famous example. It was in the 19th century, it was realized that electricity is connected with magnetism, and magnetism is connected with electricity. The one will make the other, and so on. You can write down a system of equations that captures that interdependence, and this was done by James Clerk Maxwell who at that time was working at King's College in London, where I worked many years later in the mathematics department. So the story goes, I mean, I think it's fairly close to the truth, that he thought there was something a bit ugly about the way the equations for electricity and magnetism were put together. It was as if there was a missing term. And he put this term in by hand. He thought, well, you know, nature, God, whatever, would surely choose a more beautiful set of equations with this term. And as a result of that additional term, which at the time there was no experimental evidence for, the result of that term was able to then solve the equations in a very beautiful way to show that there are wave-like solutions, and was able to deduce the speed of those waves, and it turned out to be the known speed of light. And so immediately concluded that light is an electromagnetic wave, and then radio waves are another example that come out of the theory as a result of adding that extra term to make the equations more beautiful. And there have been many other examples in the history of theoretical physics. Not sure it would work in economics or anything like that. Never heard anybody say that that's beautiful in quite the same way.
Well, maybe we'll hear that tomorrow.
It was actually absolutely tantalizing for James Clerk Maxwell, because he wrote down the equations and deduced that there would be a wave motion while he was at the family home in Glendare in Galloway in Scotland.
Oh, right.
At the beginning of the summer holidays.
Oh.
And he had a hunch that this would give waves that were the speed of light, but he needed the data which were in his house in London. And there was no email in those days. He couldn't just jump into his car and drive down to London or phone someone up. So he had the whole of the rest of the summer holidays in Galloway,
Fretting over it.
waiting until he could get back to London and put the numbers in, which is what we now call epsilon naught and mu naught,
Right.
and put them in, and discover that he was right. It was indeed the speed of
The
light.
speed of light. Yeah.
So Paul, you agree with me, and I think we probably would all agree that we'll see if my students agree that electricity and magnetism is a beautiful event.
I think so.
Where does that beauty come from?
Right. Well, of course, you can get into very deep discussions about what do we mean by beauty, and very often people will say, well, it's got something to do with symmetry, and it's true that if we're talking about the beauty of the human form, bilateral symmetry plays a part. But then we also recognize that complete symmetry is in some ways a bit unsatisfactory. So a little bit of broken symmetry seems to, in the theory of art, that seems to be accepted. And so there's something about the way that we see the world that appeals to us, which we also see in fundamental physics, because not only does symmetry play a really important part, but so does broken symmetry. And indeed, the Higgs boson comes about simply because there is a broken symmetry. So all of these things matter. But in the sense of, you say, where does it come from? You know, I said earlier that you get sense out of nature. Somehow the sense has to be put into nature. And if you want to take a straightforward view of a creator God, you could say, well, it's God who put that beauty and that symmetry and so on into the laws. You could take that point of view, and a lot of people do. You don't have to appreciate the beauty and the symmetry in nature. And so your students, I hope, will be convinced that the subject of electromagnetism is indeed beautiful.
I shall do my best.
But what you're really touching on here, which I think is the way I would express it, is that these laws of physics we've been talking about, where do they come from? So it's not just why are they beautiful, but where do they come from in the first place? What is the origin of those laws? And I have lots of conversations with colleagues about this, and those who don't want to get drawn into deeper levels, whether it's religion or some other system of thought, they don't want to go beyond it. What is their answer about where these laws come from? And after that article that you mentioned in the New York Times, Having Faith in Science, which was really about where do the laws of physics come from, one of our more eloquent colleagues, Sean Carroll, responded in a way that I found always very useful. He said, basically not wanting to go to any deeper level, that those of us who work in fundamental physics just accept the laws as they are. We just get on with the job, basically, and we don't ask where they come from. That there is a chain of reasoning that goes all the way down to the laws, and then we just accept that for what it is, and don't go beyond it. I can't do that. It seems to me that just saying, oh, it's a package of marvels that just happens to be, is something of a cop-out. It means that we suppose that our explanations of the world, of natural phenomena, are based on chains of reasoning, each of which makes sense. I've said this, and it goes all the way down until we get to these laws of physics, and then suddenly we say, oh, that's it. They're just free-floating, and like the Tower of Turtles, they're just like a levitating super turtle that we just accept without any further explanation. And I've never been satisfied with that idea. But very courageous of him to spell it out. That's what we do. It's a mystery. We won't attempt to explain it.
All right. Well, let me go then to Jennifer now. I mean, where do you think the beauty comes from?
Well, there's a question of what is beauty, and then there's the question of where does it come from. So I think the others have already said clearly that beauty is kind of hard to define exactly. Beauty's in the eye of the beholder in some ways. So, but we recognize it, when I just showed you that beautiful nebula of star formation, I think we all see the color and we say it's beautiful. So there's something about color, there's something about symmetry, whether it's visual symmetry or whether it's...
Well, you're wearing a five-fold symmetry symbol around your neck, presumably because you think it's beautiful.
Stellar symmetry.
I do
That's
too.
right. Beauty of equations. We even talk about beauty in poetry or the beauty of music. So there's something that humanity responds to that isn't simply about survival. There's something bigger that we respond to. And so I don't know quite how to define beauty, but I'm listening and learning from others who do. So I think the question is not so much where does beauty come from, but where does our ability to recognize it come from? And that to me is the deeper question. And what's the connection between whatever beauty is, but our ability to recognize it and make that connection? I think it's amazing as I just showed you kind of very quickly, but how we can use astronomy as a time machine to kind of see how the universe has evolved in time to the point where we can have life-bearing planet, at least one, and that life itself has evolved to the point of being able to ask these kinds of questions and talk about beauty and meaning and purpose. We may be able to track every single natural step in that whole progression at someday to the point where we get here, but then we still have to ask the bigger question, the capital W, why. And for me personally, that answer to that big capital W why that goes beyond the kinds of questions that the tools of science can answer leads me back to God. And I really feel that I have enough evidence, both from my observations of human nature, my observations of beauty, if you will, the match I see between what's revealed in scripture and the good and bad in human nature that I see around me, and then my own personal experience. and historically the coming of Jesus Christ, to put it all together, that for me, it's enough to say the answer to beauty and the meaning of life really is in God and is in his appearance in Jesus Christ. I think one of my most hilarious books I've ever read was Douglas Adams' Hitchhiker's Guide to the Universe. And if those of you are familiar with this famous book, part of it was that a supercomputer was tasked with finding the ultimate meaning of life, the universe, and everything. And after 7 million years, the computer came up with the answer, which was 42. And then everyone was puzzled and baffled because they didn't know what the question was. So they had the answer, but they didn't have the question. And the answer being a number wasn't ultimately satisfying. And so I think in science, while we want to know exactly the physical causes and effects and the ultimate physical origin of the universe or the multiverse or whatever, for me as a Christian, what I realize is that the real ultimate answer is not in an equation or a force. It's in a person, and it's in a living God, and in the person of Jesus Christ. And that is where I've come to in all of the bigger questions of life.
Andrew, this one came for you. It said, you mentioned that a relationship with Creator God through Jesus Christ makes science richer. Can you elaborate on that?
I wonder what kind of elaboration they're looking for.
Richer how? Let's start with that. When you say it makes it richer how?
Well, in the sense that there's the added pleasure, the added joy, not just that goes beyond the intellectual or whatever satisfaction of solving a problem or getting an experiment to work, which anybody in the field can have, and it can be very intense and very rewarding in itself. But the sense that you're discovering that in the context of a relationship, and so you're not just discovering that's how it works, but as it were, that's how God made it work. Let me try another angle on it, which relates to a quality that, like beauty, we can sort of recognize it, although it's not always easy to pin it down, and that is meaning. And if you take a painting or some music or someone performing a dance, or a number of other ways of doing creative activities, and you say, what is the meaning of that painting? What is the meaning of that dance? Well, you don't want to say it hasn't got a meaning. You don't want to say it's meaningless. You don't want to say the dance is meaningless. That would be rather contemptuous thing to say, and probably tells you more about the observer than the creator of it. But nevertheless, the meaning of a painting or a poem is a kind of interactive question. It depends both on what the creator, the painter, the poet put into it, but also how the individual responds to it. But then you could add one sort of further question, which is, could there be an impersonal meaning? Or does the very concept of meaning mean that there had to be someone who meant something, who imparted the meaning, albeit a meaning that is only discovered in interaction and can't always be articulated in words? And you can see the sort of direction of travel of this thinking, that if we ask questions about beauty in the universe, or about meaning in the universe, or in science, or, the world of tiny things that I study at the other end of the scale from Jennifer, it does prompt you to ask whether there is someone imparting the beauty or imparting the meaning. And if you think that, well, there might be, then to see the discoveries you make in the context of learning about that person behind it all is, again, I find very enriching experience.
Wow. So again, if there are more questions, again, I have no questions up here. So okay.
I have a kind of follow-up comment, if I could. Is that all right, Barry?
Yes, please, Jennifer, and I'll see if I can.
I think one cautionary note about going down the beauty trail is that what's beautiful for one might be disastrous for another. So I think of things like the wondrous formative processes that plate tectonics enables in planets like Earth. One could see that as beautiful. And yet, of course, it's plate tectonics that bring earthquakes and that can bring much death, suffering, and destruction. So, what is beauty? If I think about black holes and the fact that we're just now starting to be able to image the light right at the edge of black holes, that is incredibly cool and incredibly beautiful, but it wouldn't feel beautiful if you were suddenly right there at the edge and being sucked in, so what do you describe as good? What do you describe as beautiful? It kind of depends on your relationship to whatever that is that you're describing. And sometimes there's so much evil and suffering in the world, we don't want to get too caught up in these kind of esoteric concepts of beauty when there's so much ugliness and so much suffering and so much injustice and these kinds of things. So I don't think beauty stands alone as a way of drawing one to a certain faith. But I think the fact that it does exist and that we can contrast it with what we think is not beautiful says something about reality as well.
Okay. Well, I think the first of all, I appreciate Paul's, I don't know, do you want to call it a hunch or a gut feeling that there is something beyond that?
Deeper, yes.
Deeper than
well,
that.
I am director of the Beyond Center. So
Yeah, that's
we
right.
always
That's right.
try to go a little bit beyond. So yes. And I'm not committing, you see, to anybody's concept of a God because I'm trying to work it out for myself. And so from my point of view, I would rather the science led me to that deeper level rather than decided I believed in the existence of this deeper level and I was shoehorn the science to fit. So I'm going backwards at it, but it's clear to me. Well, I'm very unhappy about just stopping and saying, like Sean Carroll, well, that's it. It's just the way the world is. We accept it as a package of marvels that just happens to be as a brute fact. So I think that's unsatisfactory. I think there is a deeper level of explanation.
Well, you wrote a book, in fact, called, on this side of the Atlantic, I think it was called Cosmic Jackpot.
Yes, yes.
But on the other side of the Atlantic, I think it was called Goldilocks Enigma.
That's right. Why is the universe just right for life?
Can you tell us, can you summarize the book in, for heaven's sake, this is a disgraceful thing to do, but to ask you to summarize it, please be brief, in a few sentences, and where you wound up in that book.
Yes. So the book really starts out by asking the question, will human beings or our descendants ever have a sort of closed and complete explanation for existence? Because that would be the ultimate triumph of the scientific project or human inquiry generally, is we figured it all out and it all fits together and that's it. We will probably never get there, but I think scientists who work on fundamental topics are motivated by that idea of a sort of complete unification of all of nature. And we've been talking at length about particle physics, and we talked about the unification of electricity and magnetism. That was one step. But then I mentioned the unification of electromagnetism, the weak nuclear force. That's another one. And one of our colleagues who spends part of the year here at ASU. Frank Wilczek was part of an attempt to go beyond that and bring in the strong nuclear force, and then gravitation remains still a very difficult one. But there is this general feeling that there ought to be a set of mathematical relationships that unifies all of our knowledge and understanding of the universe at a fundamental, at a reductionist level at least, maybe a formula that you can wear on your T-shirt. So it's an exploration of that, but it also looks, because the subtitle of the book is, Why is the Universe Just Right for Life? That's what the Goldilocks enigma is. So we do seem to live in a Goldilocks universe as rigged in favor of life, in the sense that if you imagine playing God, if something you don't like about the universe, imagine having some sort of machine, I think I call it the designer machine, and it's got all these knobs on, dials, I think Americans would call it, all these dials, and you twiddle this dial and all electrons get a bit heavy, and you twiddle that dial and the weak force gets a bit weaker, and so on. And then you can ask the question, what would change? And the answer seems to be that with some of those dial settings, even a slight change would wreck the possibility of life ever emerging in the universe. So it looks like the existence of life and mind and reasoning beings and comprehending beings, which I think is a big part of the story we haven't really got into, that the universe is comprehensible, not just we don't just observe it, we come to understand it, but that whole thing depends rather sensitively on some of those dial settings. And this is a well-worn set of arguments, sometimes called the Anthropic Principle. And one response to that is, well, there's not just one universe, there's a vast multiplicity, maybe an infinite number, in which the dial settings are different, sort of randomly chosen. And here and there, just by chance, you'll hit the cosmic jackpot, hence the other title. And that we, of course, live in such a universe. So I wanted to look at those arguments and to unpack them and compare them with other explanations for the bio-friendliness of the universe, and really get down to these very deep questions like, where do the laws of physics come from? Why do they have the form that they do? Why are they consistent with the existence of life, indeed encouraging the existence of life? And how come human beings can comprehend these things? So all of the stuff we've been talking about this evening, but a lot more, I wanted to pull it all together into a sort of, Davies's manifesto of how I see the universe. And I used to get complaints from the earlier books. People would say, well, you write wonderfully about all these things, but we can never figure out from reading the book what you actually think.
We're big on labels. Americans are big on labels. So,
and so at the end, I've got, I think, 8 different points of view you could take. One would be Sean Carroll's, well, that's just the way it is. That's, shut up and calculate sort of thing. And then I go through all these different ones. Oh, God did it. God just made it right. And that's, part of God's plan. That's another one. And so you can get your 8 different ones. And then I say right at the end, where Davies fits in to this, somewhere between position 7 and position 8, something like that. So, in a nutshell, that's what the book is about.
What is between? So you're 7.5. What does that mean? So you're 7.5 on this Davies scale.
It means what I've been talking about, which is that I think that there is something deeper about the universe. Isn't just a package of marvels. It just happens to be. There is something like meaning and purpose. And of course, I in the book go into the fact that words like meaning and purpose are very loaded, and we have to be very careful how we use them. And so I try to avoid using anything that might create misunderstanding. But what I feel comfortable with is in saying that the universe isn't arbitrary or absurd. It is about something. The universe is about something. And so when we do push the frontiers of science, we do expect to find something that makes sense. And the fact that it's about something doesn't necessarily mean that you have to have we haven't got into this topic, and I'm talking too much because it's such a vast subject. But one of the problems I have always had with the traditional monotheistic view that you get from some interpretations of monotheism is the notion of God as a miracle-working super being who predated the universe, that was there for all eternity, then pressed a button, made the Big Bang go bang, and then presides over whatever happens subsequently and occasionally intervenes to a bit of mid-course correction. Never felt happy about that idea at all. But there is, of course, the alternative tradition in monotheism of God as a timeless being outside of time altogether, and the time as part of creation. So the modern understanding of the origin of the universe is not that for all eternity there was nothing and then suddenly, boom, there's a universe. It's that time itself began with the Big Bang. Now that's all revised if we go to the multiverse theory, but this for me was a really essential point, that I hate the idea, well, I don't hate it, but I find it not very satisfying, the idea of a pre-existing deity within the stream of time. So I would like time itself and space itself to be part of the universe, and that's what we believe in physics. But I come back to the underlying laws. So we can say this is getting. I really should have given a properly constructed lecture, but people worry about what is the cause of the universe, and they say, well, God caused the Big Bang, something like that. But I think that's an abuse of terminology, because cause and effect implies the existence of some temporal relationship. And so I think we don't need a God to cause the Big Bang to go bang. However, that doesn't mean we've explained it. We haven't explained the universe by just saying it doesn't need a cause. If you say the universe pops into being from nothing, I can accept that. But we still haven't explained the universe. So I see, when I think of, I try not to use the word God because it means different things to different people, but it is something along the lines of Tillich's, ground of being. I see, if I use the term God, it's the rational ground in which our explanation of the order in the universe is rooted. And I believe there is such a rational ground, that it's not just all free-floating and just amazing and with nothing underpinning it. But that's a very far cry from most people's conception of God. Probably most people in this room have an idea of God as a person, eternal in the sense of having always existed for an infinite amount of time. I don't like that and never have liked that idea. So I've been rambling on. I'm sorry.
Yeah,
I do apologize.
I think this is.
But you asked me. So.
It's really important to. I wanted to parse such views. So Andrew, if I may prevail on our friendship. Oh, now he's scared. I am.
I'm terrified.
So
I think you meant presume rather than prevail.
Well, okay, whatever. Yeah, presume. That's right. Yeah, I'm not going to put a gun to your neck, but I'm going to ask you. Tell me about the God you believe in and why you believe in him.
Well, with great pleasure, and I think I would.
Paul, I hope you won't be offended, because he just talked about how awful he thought it
was.
was.
He's going to say Paul's talking absolute drivel.
No, okay, I don't think so. Actually, I don't know. Maybe you can find something I'm going to say that's at variance with Paul, but I think I start with an evidence-based approach. I feel this is a realm where speculation is not going to be terribly useful. And the evidence-based approach I take is the documentary and other evidence that we've got for the person of Jesus Christ. And we actually know quite a lot about Jesus, and it stands up to pretty robust scholarly examination. And out of that emerges a person who is just absolutely astonishing. so remarkable. And we're all gonna serve somebody, as Bob Dylan put it. We're all gonna find something or someone that we worship and pursue.
I worry that we're talking about Bob Dylan and Douglas Adams. We have a lot of young people in the audience. So,
I'm so sorry.
But anyway, go ahead. Keep going. Keep going.
It was a song by Bob Dylan for which the refrain was,
That's right.
You got to
serve
somebody.
It may be the devil or it may be the Lord, but you got to serve somebody.
If you could just sing it, Barry.
We'll save that for Chorus 2023. Okay.
And I find the person of Jesus to be so amazing that I find myself wanting and choosing to follow him. And then you begin to look at his recorded claims and what those who were closest to him said about him and wrote about him. And then you can sort of, as it were, zoom out to the greater context in which he was, including the cultural and literary and geographical and historical context in which what we know about him was set and the life he lived was set. And in particular, his claims to be in a way that, Paul's talked about, this needs a whole series of lectures, but the way that he did claim to be God, and people said about him that he was God embodied in a material form. And I suppose the one bit of experience that I might add to that very short summary was a time when, as a student, I was given a scholarship to spend a month on a course based in Jerusalem on the geography and archaeology of Israel. And I found this a hugely enriching experience. It was great fun. It was absolutely fascinating. It's amazing what you can discover. And we had a day with 2 nights, 2 nights and a day between them, staying at the top of a mountain in Israel called Mount Tabor, which was a sort of funny name for me because my professor at Cambridge for my PhD was David Tabor, so same name. And we had free time at the top of this mountain, and there was no program or anything. You could just, sit thinking, and in my case, sitting and looking out over the vale of the valley of Jezreel. And the thing that came to me very clearly then was that for intellectual integrity, I had to bring together what I had on the pages of the Bible with the material existence in time and space in which the events described in the pages happen. So I had this beautiful Bible that I'd been given as a baptism present by my godmother. You can imagine, sort of leather binding, India paper. And it was very easy to keep that in a sort of separate intellectual compartment in one's life. And what this, I found myself realizing this day at the top of Mount Tabor was that didn't stand up to scrutiny. And that so much, well, of course, the Bible is a vast and rich collection of literature, but the narrative parts of it were narrating things that had taken place in time and space, in the sort of place where I was spending that month. And that for me was very helpful, and it affects the way that I follow Jesus Christ, but it also affects the way that I think about the relationship between my knowledge of God, such as it is, and the material world, such as I'm able and privileged to study in a little way through science.
All right. So I've been given, Jennifer, I was going to go to you, but I think I'm going to have to take you off the hook because I've been given the signal to wrap up. People keep, all right, boy, now the audience is doing this. It must be time to go.
They're just talking about me, I think.
Oh, I don't know. Maybe it's my tie. I don't know. First of all, I really want to thank each of you personally for your willingness to dialogue with me tonight. This is a subject that is personal, is very personal, and I appreciate the fact that you were willing to share your thoughts. The other thing, if you remember how we opened when we were talking with Marissa there, I talked about how the atmosphere for discussions about questions like this was toxic here. And I hope that at least those of you who have watched this have seen that atmosphere has been clarified considerably. I consider Paul a dear friend, Andrew a dear friend. Jennifer, we got to get together sometime, but I'm going to call you a friend anyway. But at any rate, I think it has been a sincere and honest conversation about the relationship of science and faith. And so please join me in thanking our panelists for sharing.